Okay, example number 2. I will now read the problem. So I want to remind the students, just now what we learned, two parallel lines crossed by the same line. We have this angle 1 would equal to the angle number 2. But there is another property. So for congruent angles, angle 1 would equals to the opposite side of its own, right? So this angle 3 would equal to 1. Since 1 equal to 2, so 3 equals to 2 as well. So this is a very important thing. For two parallel lines, you have the angle on each side of the crossing line. Angle 3 and 2, these two angles are the same as well. Okay, the other pair that we can find is this angle, this big angle, would equals to the angle on the other side of the line here. These two are the same and these two are the same, the opposite, the crossing pair of angles. So using these two properties, angle 1 equal to 2 and the cross pairs equal, then we can solve this problem. So we know this angle is 22. I just draw a bigger picture here. This angle is 22. This larger angle is 71 here. And we want to find what's the angle down here. Okay, first of all, at this vertex, we draw a dashed line. This dashed line is parallel to line M and line N. Say this is line L. Two parallel lines, 22 would equals to the angle opposite of its own, like what we have here, 3 and 2, right? So 22 is here. This angle is also 22. We know this total angle is 71. So this little part is 71 minus 22 degrees. And this line L parallel to line M, this part would equals to the opposite side of this angle. So this angle would give you 71 minus 22 degrees. Number 3, in the diagram on the right, we have AB parallel to line CD and AD parallel to BC. This is a typical parallelogram. So if angle A is 73 degrees, what's the angle for angle C? So this one, we can do it in many different ways. Okay, here I'm going to show one property of any parallelogram. The four angles would add up to 360 degrees. Why is that? For any shape, we can draw a line of the diagonal side. We know the internal angles for any triangle is 180 degrees. Now you have two triangles. So the total internal angle would add up to twice of that. So that's a 360. So remember, any shape, doesn't matter. It doesn't, as long as it have four sides, the internal angle would add up to 360 degrees. And the other property for parallelogram is you have the opposite side, the angle would be equal to each other. Okay, the D equals to the B and A equals to the C. So using this property, you don't really have to calculate. But using 360 degrees, you can calculate what's the angle for B and D. So basically, since these two are the same, these two are the same, so A and D would add up to 180. So 73, you know, you can use 180 minus 73 to get to the D. Number 4, lines M and N are parallel. Two rays are drawn here. Now you know this angle is 46 and this angle is 31. What's the angle A here? Again, there are different ways of doing this. I'm going to show one example. This is two parallel lines. This is a 46 degrees. This angle would be 46 degrees as well, right? 46. 31 degrees is here. This little angle inside this triangle is congruent to this angle, so that's 31. Now we use the property, if for any triangle, the internal three angles adds up to 180 degrees. Now for this small triangle at the tip, you know one angle is 31, and this big angle with the 46 adds up to 180 degrees. So you know this big angle is 180 minus 46. So you know two angles. The A would be 180 total for the whole triangle, minus one angle, minus the other big angle, which is 180 minus 46. This would be for your angle A.